Welcome back to the lecture series on microeconomics. Let us continue with the discussion on the properties of indifference curve and various shapes of indifference curve. We have listed down 4 properties of indifference curves. Now, if the indifference curve follows these properties, what kind of shape will that be? So, let us examine that. Focus more on the convexity axiom. Convexity can be of two types, strong and weak. When we have drawn this convex to origin indifference curve, we are assuming strong convexity. So, by strong convexity we mean that if you take 2 points on this indifference curve and if you join these 2 points or commodity bundles by one straight line, then that straight line will lie right to the curve entirely. And what do we mean by weak convexity? So, again you take 2 commodity bundles or points on this indifference curve, if you join them by a straight line, then either the straight line will lie right to the curve or it will coincide with a part of that curve. So, if weak convexity holds, there is a possibility that we may not get a convex to origin indifference curve. So, in that case the indifference curve can have linear segments. So, if weak convexity is ruled out, if we assume only strong convexity, then that also has this implication that the indifference curve cannot touch the either of these axes. Now, what are the other implications of strong convexity? Convexity is really important in economic analysis, and that is why we are focusing more on this convexity property of the indifference curve or iso-utility curve. So, now we are going to talk about the first implication of convexity. So, if the consumer has 2 commodity bundles X and Y, and if we can assume a theta such that it takes value between 0 and 1, then we can construct a consumption bundle, an average consumption bundle, which is a convex combination of the bundles X and Y, and that average bundle will be preferred over either the X bundle or the Y bundle. So, the implication is very simple here. The implication is that a consumer in general likes average over the extremes. Now, let us look at the second implication of convexity. We have already said that if we assume strong convexity, IC can't touch axis. Now, let us move on to the third implication, and this is very important in consumer analysis. This is known as the law of diminishing marginal rate of substitution. Now, what is diminishing marginal rate of substitution? For that, we need to first define marginal rate of substitution. Marginal rate of substitution gives the maximum amount of a good that the consumer is willing to give up in order to get one extra unit of another good such that the consumer still gets the same level of utility. So, this is the definition in words. Let us see what does this mean in terms of mathematical language. We have already seen the definition of marginal rate of substitution. Now, let us see how we can define this in mathematical terms. So, marginal rate of substitution between two goods 1 and 2 is defined as the negative of the slope of the indifference curve. Remember, on indifference curve the utility is fixed. So, we need to write this. So, this tantamounts to the ratio of marginal utilities. Now, we say that MRS 1 2 declines as one consumer moves rightward along an indifference curve. It implies as he or she continues to consume more of good one. It implies x1 in our case. Now, if we want to show this graphically, then let us draw this graph. So, x1 measured along the horizontal axis, x2 quantities of quantity 2 measured along the vertical axis, and we have an indifference curve convex to origin, a conventional indifference curve denoting utility level u naught. Let us draw a line which is tangent to this point A, so that we can measure the slope of this indifference curve at point A, and let me name it P Q. Let me have another straight line drawn, this time tangent to point B, and let me name that line P dash Q dash. In that case, MRS at point A would be OP over OQ. Similarly, MRS at point B would be MRS 1 2 B OP prime divided by OQ prime. So, from these expressions it is obvious that MRS at point A is higher than or greater than MRS at point B. So, what is happening here, the absolute value of the slope of the indifference curve is falling as we move downward along an indifference curve. Now, what does it mean economically? For that, let me construct another graph. Now, note, as the consumer consumes 1 unit of clothing and some unit of say food, we are on this point, we are at this point on the indifference curve. Now, as the consumer has increased the units of clothing to keep him or her on the same indifference curve or the same satisfaction level, the quantity of food has to go down, and suppose we say this is the point, and then the consumer continues to purchase more and more of clothing to keep him or her on the same indifference curve. We have to reduce his or her consumption of food, and the consumer moves to a point say C. So, this way the consumer makes his or her journey along the indifference curve, and he or she is moving rightward, right. Now, what does that mean in terms of MRS? So, note that the consumer initially was willing to give up this much of food for 1 unit of extra clothing. Once the consumer reaches point B to get another unit of extra clothing, now the consumer is willing to sacrifice some unit of food, but that magnitude of sacrifice has gone down. Now, the consumer suppose moves from point C to point D, and you can very well see from the graph that although the consumer is still willing to give up some units of food, it is fewer units of food compared to the previous cases. So, one may ask, what is the reason for this? One can cite two different reasons for this. One is this: as the consumer increases consumption of one particular commodity at the expense of the other, the intensity of desire to have more and more of that commodity falls because of the law of diminishing marginal utility. Because as the consumer is sacrificing one good, that good's marginal utility is increasing because the consumer is having less units of that good. The other reason could be that in world when we consume goods, not all of them are substitutes of each other. So, in that case the consumer would like to consume an average bundle where the consumer has something of almost all commodities that he likes or requires. So, here in this case what we have seen? We have food and clothing. Now, can the consumer live with only food, or can the consumer only live with clothing? No, the consumer requires both. So, of course, after some point of time the utility of one extra unit of cloth or one extra unit of food starts falling for the consumer, and that leads to this convex indifference curve or the diminishing marginal rate of substitution, because finally the marginal rate of substitution basically gives a trade off between two commodities such that the consumer remains with same level of satisfaction. Now, a question that automatically comes to our mind is that, is there any linkage between law of diminishing marginal utility that we have seen in the case of Marshallian consumer theory and this diminishing marginal rate of substitution what we are finding in the ordinal approach to consumer theory? We are going to study that right now. So, for that we need to look at the mathematical expression of the slope of MRS. Now, let us look at the final expression. I am not going to derive step by step, I am just going to state the final result and then we will explain. Now, note that these u1 and u2 are the marginal utilities. So, these are the first partial derivative of the utility function with respect to the respective commodities, and as we know that there is axiom of non-satiation, we can assume safely that they are positive. Now, let us look at these double partial or the second order partials. So, u11 and u22. As we have already assumed that there is law of diminishing marginal utility, we can again assume that these will be negative. Now, to have diminishing MRS, we require sign of this above expression to be negative. Now, it is impossible to comment on the sign of this expression, because although we can certainly assign signs to u11, u22, u1 and u2, we cannot do so for this entity u12, and hence we cannot comment on the sign of this del MRS del x1 in a straightforward manner. Now, having stated these properties of IC, we have seen that in general indifference curve is going to be convex to origin. Now, a question automatically comes to our mind: if we violate some of the axioms, if we violate some of the properties of indifference curve, then what sort of new shape of indifference curve are going to emerge, and this is going to be the subject matter in last few minutes of today's discussion. First, we are going to talk about three different shapes of indifference curve, and we have names for them. So, we are going to consider, or we are going to study three types of indifference curves which has non-convex shapes, and we are going to discuss them one by one. So, first let us start with the case of perfect substitutes. Now, in the case of perfect substitutes, which assumption or axiom is violated? Let us study substitutes. With the help of a graph. So, the substitutes are considered to be very similar kind of goods. You can treat them as almost one good or the same good. So, you know it it is easy to understand the substitutes through examples. Let us take the case of pen. So, if I have to write down something on a piece of paper and somebody gives me a black pen or somebody gives me a blue pen, it does not matter, it is a pen to me, and with that pen I am going to write. So, a black pen or a blue pen is basically perfect substitutes. It gives almost same kind of satisfaction to the consumer. You can also think about Coke or Pepsi. Suppose you are willing to have a cold drink, you are thirsty in a hot summer day. So, it until and unless you really have some kind of restriction set outside, or if you have some kind of very strong brand loyalty, there is no difference between a bottle of Thumbs Up or a bottle of Coke or a bottle of Pepsi. So, these bottled soft drinks are perfect substitutes to each other. So, if that is the case, then what type of shape indifference curve will take place? Note, as the marginal utilities are almost same from these substitute goods, the MRS, the marginal rate of substitution, will not decline as one consumes more and more of the one commodity. So, MRS here in this case will be constant. So, if MRS becomes constant, then we are expecting a straight line, of course, because MRS is the negative of the slope of the indifference curve. So, let us draw So, in the case of perfect substitutes, the indifference curve will be a downward sloping straight line. And how to write such a preference in terms of utility function? So, this kind of preferences will be presented through utility function of this form. Where A and B are some positive parameters, and these are the values of these commodities 1 and 2 respectively to the consumer. Now, what will be the MRS? As I have said, that MRS will be a constant in this case, and the MRS value will be the negative of the slope, which is in this case going to be A over B. Now, let us take an example of perfect substitute goods. Let us assume a consumer who has one 5 rupee coin and 5 1 rupee coins. Now, in that case the consumer will be indifferent between 5 rupee 1 coins and 1 5 rupee coins. So, of course, we are going to have a straight line indifference curve in the consumption plane. Now, if we draw how that graph is going to look like and what will be the MRS. So, in that case, if we plot a number of rupee 1 coins along the x axis, and if we measure the number of 5 rupee coins along the y axis, then we are going to have intercept 1 along the y axis and intercept of 5 along the x axis. So, in that case MRS is going to be 1 over 5. Now, study the case of complements. Which axiom is going to be violated if we are going to experience complement goods? The axiom of dominance is going to be violated in the case of complements. So, again we will try to understand complements through examples. Complements are commodities which are used in fixed proportions. So, let us consider two examples. You consider left shoes and right shoes. So, these are used in fixed proportion 1 to 1, and that is why these two commodities are perfect complements. You can also consider your morning cup of tea or evening cup of tea. Suppose there is a consumer who has this preference that he or she adds 2 teaspoonfuls of sugar to every cup of tea. So, in that case there is a fixed proportion of half between cup of tea and teaspoonfuls of sugar. In this case tea and sugar will be perfectly complementary goods. So, if two goods are perfect complements, how to draw indifference curve in this case? Again, so suppose there is a fixed proportion that the consumer uses to mix these two goods to consume them together, and if we know that proportion, we can draw a straight line whose slope is going to give us that proportion. So, in that case all these points along this straight line will give us the consumption bundles, right. So, if now the consumer is given some more units of x2 given the unit of x1, these extra units of x2 does not have any utility or satisfaction to the consumer, because he has extra units of x2 compared to the units of x1. So, he will be indifferent between this point that we have already drawn here A and say a point B here. Similarly, if the consumer is given some extra units of x1, but he or she is not given extra units of x2, then the consumer can be here say a commodity bundle C. So, in that case also the consumer is indifferent between this bundle A and C, because he cannot use this additional units of x1 as he does not have those many number of x2. So, in this case the indifference curve will take this kind of right angled L shape, and this corner point will be the point of consumption for the consumer. So, in this case of complements, perfect complements, we observe that indifference curves are going to be right angle curves. Now, how to represent perfect complements kind of goods or preferences through utility function? Well, in general one can write this type of utility function So, now let us consider the case of this tea and sugar. So, I said that there is a consumer who mixes 2 teaspoonfuls of sugar to 1 cup of tea. Let us assume x denotes the cups of tea and x2 denotes teaspoons of sugar. So, x1 over x2 is 1 over 2. So, now note from here we can rewrite this in two ways. One can write 2x1 equals to x2, or one can also write x1 equal to x2 over 2. So, if we follow the expression 1, the utility function becomes if I follow the expression 2, then the utility function becomes so this is the type of utility function that is used in the case of the perfect complements. So, what will be the marginal rate of substitution MRS in the case of fixed proportion utility function where we see L shaped indifference curves. Now, it is very interesting to note that for this kind of indifference curves we have a kink point. So, there is a kink that is at the corner of this L. Now, if you want to draw a straight line through that point, you can draw multiple straight lines. So, basically the slope is indefinite. So, that is why the MRS at this corner point or the kink point is also undefined. But what happened to the arm of this L which is parallel to the x2 axis? For that, of course, the slope is infinite. So, MRS is also infinite. What happens to the arm of this L shaped indifference curve which is parallel to x1 axis? The slope here in this case is 0. So, MRS is also 0 in this case. We stop here for the moment. We will continue this discussion in the next lecture.